Hello and welcome to Selection with Sathi. Today we explore protocols and abstract base classes from Fluent Python Chapter 13. We'll learn duck typing, ABCs with the ABC module, and the modern protocol approach for structural subtyping. These concepts are essential for writing flexible, well-typed Python. Duck typing is Python's default approach to polymorphism. If it walks like a duck and quacks like a duck, it is a duck. Python doesn't check the type of an object, it checks if the object has the right method. Lay of obj works if obj has ______, regardless of which class it belongs to. You never need to declare implements interface like in Java. When duck typing isn't enough, abstract base classes enforce an interface. Import ABC and abstract method from the ABC module. Define your ABC as a class inheriting from ABC. You cannot instantiate an ABC directly, Python raises a type error. All subclass must implement every abstract method, or they too become abstract. The @abstract method decorator marks methods that subclass must override. You can combine abstract method with class method or property decorators. ABCs can also have concrete methods, regular methods with implementations. If a subclass forgets to implement an abstract method, the error occurs at instantiation time, not at class definition, so you'll see the type error when you try to create an object. Typing.Protocol brings static duck typing to Python, introduced in PEP 544. You define a protocol class listing the required methods with their signatures. Any class that has those methods satisfies the protocol, no inheritance needed. This is checked by type checkers like mypy and pywrite at analysis time, not at runtime. Protocol is available since Python 3.8. Virtual subclass let you register a class with an ABC without inheriting from it. Call MyABC.register passing the class you want to register. After registration, isinstance of obj, myABC returns true. But the registered class doesn't actually inherit any methods from the ABC. This is useful for third-party classes you cannot modify.
Let's build a Tombola ABC, a lottery interface from Fluent Python. Class Tombola inheriting from ABC. It has two abstract methods, load, which adds items, and pick, which draws one at random. A concrete lotto ball subclass implements both methods and works fine. But if you try to instantiate Tombola directly, Python raises type error. You cannot create instances of an abstract class. Now let's define a sortable protocol. Class sortable inheriting from protocol with a single method, ___LT__ returning bool. We write a function my_sort that takes a list of sortable items. Any class that implements __LT__ automatically satisfies this protocol. No inheritance needed. The type checker verifies structural compatibility. This is static duck typing in action. By default, protocols are only checked by type checkers. But adding at runtime _checkable above the protocol class enables isinstance checks. We define a drawable protocol with a draw method. Circle has a draw method but doesn't inherit from drawable. Yet isinstance of circle, drawable returns true. Important caveat, runtime _checkable only checks method names, not signatures. Let's compare ABC versus protocol side by side. ABC uses nominal subtyping. The class must explicitly inherit. Protocol uses structural subtyping. Just having the methods is enough. ABCs enforce at runtime during instantiation. Protocols check at static analysis time. Use ABC when you want shared implementation or state. Use protocol when you care about behavior, not class lineage.
Key tips to remember. Start with plain duck typing. Only reach for ABC or protocol when you need the contract. Prefer protocol for type hints. It doesn't force inheritance on callers. Use ABCs when you want to provide default implementations alongside the interface. Remember that at runtime_checkable only checks method names, not their signatures or return types. For more concept videos like this, download the Selection with Sathi app. Like and subscribe. Thank you.